Welcome to Statics.
Example: solving equilibrium problems in 2 dimensions. In this example, we have a member composed of a single element from A to B. This beam is subjected to 3 loads at points C, B, and D. The beam has a roller support at point A and a pin support at point B. We will find the support reactions at A and B. We call a member that has a pin support at one end and a roller support on the other a simply supported beam. I will begin by drawing a free body diagram of the body. In place of the roller support at A, I have a single reaction force. Draw normal to the surface the roller rests on. The surface is horizontal, so the reaction force is vertical. I will call it AY. The pin support at B causes a single resultant force, but for convenience we break it into a horizontal component, I call Bx, and a vertical component, I call By. The next step is to write my equilibrium equations and solve for my unknown reaction forces. I have 3 unknowns, so I will need 3 equations. I can sum forces to 0 in the x direction and the y direction. I will also need to sum moments to 0 about some point. Now, to simplify things as much as I can, if I can find an equilibrium equation with just a single unknown, then I should solve it first, to save on the algebra work. If I sum forces in the y direction, there will be 2 unknowns, AY and BY. If I sum forces in the x direction, however, there will only be 1 unknown, BX. I will do it first. Summing forces in the x direction, I get positive BX plus 600 cosine 45 equals 0. Solving for Bx, I get negative 424 newtons, which means Bx is pointing the opposite direction from the way I have it drawn in my free body diagram, so to the left. This makes sense since Bx needs to balance the horizontal component of the 600 Newton force acting to the right. Next, I will sum moments to 0. I can do it about point A or point B. I will use point A first. There will only be 1 unknown, By. Since the line of action of AY passes through point A, it is not included. Summing moments about point A, I have the vertical component of the force at C times its moment arm, 2 meters. It is negative by the right-hand rule. Next is the force at D, 100 newtons, times its moment arm, 5 meters, also negative by the right-hand rule, minus the applied force at B, 200 newtons, times its moment arm, 7 meters. And finally, our unknown support reaction force, By, times its moment arm, 7 meters. It is positive, based on the right-hand rule. Bx does not show up in the equation because its line of action passes through point A. Setting it all equal to 0, and solving for By, I get positive 393 newtons, or 393 newtons acting upward. Now there is just reaction AY left. I can get it by summing forces in the y direction, or by summing moments about another point. The simplest option is to sum moments about point B, since all of the forces acting at point B will not be included. Summing moments about point B, I get negative AY times 7 meters plus the vertical component of the force at point C times its moment arm, 5 meters, plus the force at point D times 2 meters, all equal to 0. Solving for AY, I get positive 332 newtons, or 332 newtons pointing upward. How can we check our answers are correct? One option is to sum forces in the y direction and verify that they sum to 0. And they do.